Alright, my sauce is getting super close. Hopefully it's looking appetizing to you. Um, but clearly I've made quite a mess on my stove and I'll need to clean that up later, which is obnoxious, but I'll survive. Let's do this last problem so that I can eat my food and go to sleep. Population of radioactive ducks live in a pond. Darn you, nuclear waste. When the ducks defecate, they emit a toxin that can prove fatal to certain fish species. I swear this is a true story. A study has shown that the average daily level of toxins in the pond is given by the function R of n equals the square root of 2n cubed plus 3 parts per million when the population is n ducks. It has been estimated that t years from now, the population of ducks in the pond will be given by the functions n of t, so the number of ducks with respect to time, equals the square root of 4t plus 16 plus 5, for whatever strange reason. Find the composition of functions r of n of t and explain what it represents. So we need to take this function n of t, we need to shove it into this function in the spot for n. So r of n of t will equal the r function, the square root of 2 times n, but instead of n we need to put n of t, the function. So 2 times the square root of 4t plus 16 plus 5, gross. That entire thing is in parentheses, and that entire thing is going for that n right there. So we need to cube it, and then add 3 to finish the r function, and all of that is under the square root. Gross, ugly, disgusting. But that is r of n of t, and explain what it represents. Well, if r of n is the parts per million of toxins for n ducks, and n of t is the number of ducks after t years, then r of n of t is the average daily level of toxins after t years. So average daily, yep, that's how you spell it, daily level of toxins after t years. Okay, you can see why that could be useful, hopefully. What is the current average daily level of toxins in the pond based off of these models? Well, that's saying when t equals 0, what is r? So what is r of n of 0? Well, just type this into your calculator and find the y-intercept. That's what it's asking you for. To type this in, you should do a square rooty thingy, which if you're on an 83 will give you that. And then 2, then parenthesis, then another square rooty thingy for x plus 16. Close off the first square rooty thingy. If you're on 84 at this point, hit the over button so that it stops your your inside square root. And then we have plus 5. Close the parenthesis around the square root. Cube it. Plus 3. And that's it. You can put another parenthesis to close it off, hit another arrow if you want to, but graph that with a standard window, see what it looks like. It looks pointless, and it just shows you axes, and you don't see anything. So my trick for when I do that is if I don't see anything, I hit zoom 0. It gives me a zoom fit, and it will adjust the y values for the x values that you have. And when you do so, luckily, then it shows you this thingy, dot, 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 down there. It means you're not seeing the x-axis, but it does show you a graph that looks like that, which means I can find my y-intercept. So I'm going to hit the trace button and 0, and it's going to tell me that when the time is 0, the number of ducks is 38.223. But you can't have a fractional number of ducks. Yeah, so it's probably 38. All right. Well, what about C? If the level of toxins in the pond reaches 59 parts per million, the fish will start to die. How many years will it be until the fish start dying from the duck poop toxins? Well, if that is y1, let's go ahead and graph y2 equal to 59. That way, we will be able to see when those two graphs intersect. It'll give us a line like that. Boom. And where they intersect will represent the number of years when the toxins reach 59 parts per million. So y2 equals 59. Second, calculate, intersects, enter, 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 and we get t equals 8.339 years. And that is our answer. And we're finished with our learning guide. And it is super late. It's 10:58. It's time to eat some food and go to sleep. Dinner! Yay! I guess I'll show you my food on the study guide videos, review videos, whatever you want to call it. Blah! Bye!